Hey guys, it's Chuck, outside Screwball. Thanks for stopping by the shop for a visit. And got to be honest with you, tonight's going to be another summer rerun. Just busy around here, grinding balls. This video is about the product SCREWYBALL, multi-access work holding. Currently I'm selling 3 different sizes, a 9/16, a 1 inch, and an 1.5 inch Screwy ball. The Screwy ball is a hardened steel ball, roughly 60 to 64 Rockwell, and it has a flat ground on the back side, on one side. And I will take you through some uses of how this tool can work within the Kurt vise or standard milling vise. So I'm going to do some rearranging and we'll be back and look at a couple of work holding. So the setup I have here is to show the 9/16 ball and a method that could be used. I mean, it's up to your imagination in your work holding. But here's a piece of aluminum that's rough sawn cut, and for talking purposes, let's say we needed to punch a couple of holes into there. So what I would do is with the assistance of a magnet, because the small ball is difficult to hold, I would position the Screwy ball there in place, get the part in, and I'm working around the camera here, guys, and you can see that the ball is putting pressure against the part there, and a little tap down, and the parallel, it's good. It's sitting hard on the parallel, and it's held tight into the vise there. So that's just showing you small ball use, and like I said, there's a variety of ways that you could end up using this device to hold in the vise. Alright, I'll do another setup for you. Okay, here's another setup. So here's a piece of stock. You can see it's got welding on this bar here. It's got welding on the top. This one side is fairly surfaced. So let's say you needed to knock off this weld or work on a piece. So there's a parallel down in the vise. Part would sit on the parallel. This is showing the 1 inch Screwy ball, and you can see it's there on the pressing against the rough part. It's down on the parallel. You can hear it's nice and tight. So that way the jaw is not hitting where this weld is, and we got a good tight fit in the vise for holding. And show you one more setup. This would be using the 1.5 inch ball. Back the vise out here. So here's a piece of aluminum, and you can see where some samples here where the ball will leave a dent, so you have to be careful on your part. But here's a piece. We set it up on a parallel again, and we could use the large ball in this scenario. And you can see again the part's firmly down on the parallel, and we got a nice tight fit with an irregular surface. Okay, so just a few examples of how the Screwy ball works within the milling vise or even a standard shop vise on the workbench. Hope you guys purchase the product, and hope you find many uses in your shop. Just a follow-up here. Currently only the 1 inch ball is being sold on eBay. I will be selling the other balls individually or in a set, and the set could be sold either without a box or I'm planning on having the set installed in a box for shipping and for use in the shop. So keep an eye out. You can always go ahead and contact me at this email address. You can purchase directly through the email address, or you can keep your eye out on eBay for as I add more product online. My screwy balls and making some jigs to hold the balls. So haven't really gotten much done around here in any kind of new projects other than grinding. So the rerun is of the copy that I did on a Enerpac TOEJACK. You may enjoy it again. It didn't get a lot of views back then, and forgive me for probably the little bit of poor quality. Some of that I was doing in PowerPoint back then, but I think you'll find it maybe enjoyable. And the TOEJACK, in the final episode, I named it the Mitchell. That was after my buddy Steve Mitchell, and in that video I mentioned that he had ended up with cancer in his jaw, and to just bring you up to the date, he's still fighting the fight. That video I think is over a year old. He's not out of the woods yet. He's on experimental drugs to fight the cancer, the tumor that's there. And as I said in the video that you may watch, if you stick around, he's my hero. He's one of the strongest men I know. I'm going to go handheld here for a minute, just show you a couple little things going on here, and other than that, catch you next Tuesday and hope to have you something new. So here we go. Yeah, of course, there goes my lights like usual, right? So, a little handheld. Of course, the camera gets stuck. So you can see, no cleanup here. Been doing a little aluminum work, making jigs for the surface grinder. So there's one jig that I made for 1-inch balls, and you'll see I'm holding it in a vise down there. I was using this collet holder. I'm still using it for the 9/16 balls. And down here, see a little bit of aluminum dust there on the saw. And down here's the jig that I'm using for the 1.5-inch balls. So I've just got it set up in an old mill vise right now. What will end up actually happening is this piece, rather than being held in a vise, will end up with bolts through it to secure it, and then a metal inset on the bottom so that it can secure to the mag. It'll be a fairly quick setup. This is working well, but it's just a lot of weight on the mag chuck going back and forth. But it's working. So we're making balls. The only other thing going on in my shop is my Chewy, my mentor. He repairs pool cues for a hobby and a little side money. And you can see he turned my lathe into a wood lathe. Doing a repair there on a cue stick, which we've done in the past here. Okay, well, that's about it. And bring you back around here for a second. I don't know if I'm in frame, but thanks for stopping by, and see you again next Tuesday. Hope you enjoy the rerun. If you don't, just start hitting fast forward and get your way out. Take care. Hi guys, it's Chuck. Welcome back. And I just want to say hello to all my new subscribers. Got quite a few. I know I haven't posted anything in a bit. Life got busy, and been trying to play out in the shop, but haven't had much time. A little bit that I have been doing, I rough cut these parts a month ago, and the little time I've been coming out and building these stack blocks. You can find them on Tom Technique's channel. It's a great channel, lots of education, and although these little stack blocks look simple to build, which they, in a sense they are, it's a great little learning tool, and believe me, I've been learning. Other than that, the trunnion that I built some time ago, there's a video on it. That came back. The fellow that gave me the directions, my mentor Chewy, he didn't notice that the radius sat on a boss, and so I had to open up the radius to fit the boss. Did that real quick since I still had the tooling that I had set on the rotary table. Only took a few minutes to set it up and do it. I didn't film it. And other than that, I've some recent purchases that I thought I would show you. I'm kind of excited. And then I've got a brainstorm or a brain fart on making a tool, and I thought I'd share that with everybody. So I'm going to pick the camera up, take you on a quick tour, and we'll go out and look at my upcoming project that I'll share with everybody. All right? So I'll try to keep the camera as jiggle free as I can here. So the first item is over on my lathe. I ended up purchasing a stock Clausing steady rest for it. I found it on eBay. It's the unit that actually is built for my lathe. I've got a 6913 lathe Clausing, and you can see it. There's holes there, and that's where it bolts down. Interesting enough, it was on eBay for a buy it now at 125 bucks, or bid on it, and I decided, oh, I guess I'll bid on it, and so I put a small bid in, and of course then the buy it now went away, which shocked me, and I thought, boy, I don't want to lose that for 125 bucks, and so I ended up bidding and finally won it at $129. So I'm real excited about that. I do have to, it's missing one of the adjusting bolts, but that's not a big deal. So that's new to the shop. I picked up another Procurnier tapping head. This is a larger unit than the one I have. I picked that up at a sale the other day. So I've been playing around with that a little bit. And some other purchases. Ended up buying 4 of these what do they call them, the Spill Master cups, and purchased a small Noga indicator holder, the little guy. I do have the bigger one over there, and the other day Enco had 20% off and free shipping, and this little guy was already on sale. Take another 20% off. That was a good buy. So some new additions to the shop. You can see the stack blocks. There's 3 sets there, and then there's another 3 sets over in the mill that I've been playing. You know, when I come out and get a little bit done on them, been working on it. And you can see I haven't spent much time. The place is quite a mess. Oh, interesting thing here. I'm questioning whether I'll ever buy anything from Harbor Freight or not. The other night when I'm working out here, the air gun, as you can see, there's no fitting in it any longer. I'm kind of happy. I'd happened to walk away from the mill, and next thing I hear pop and air running like crazy, and this guy is knurled, and it blew right out of the gun. Wasn't happy about that, and maybe that's what you get for buying Harbor Freight. I looked at the other gun that I have, which isn't Harbor Freight, and I forget where I bought this one from, but interesting enough, it's basically pressed in the same way on a knurled setup. I thought maybe this was constructed better. I like this gun better, but I don't know about any more Harbor Freight purchases. And then one other item that came up in discussions, my ox tool mill brush, right? That luckily my wife had this laying around the house and I grabbed it. I had mentioned that I'd set it up with a magnet on the side of my DRO head, and there was some discussion about whether the magnetism was going to affect the DRO head. Well, I think you can see that there's quite an airspace between the DRO head and the bracket, and I've put something behind there, and there's no magnetism to the back side, and it's just a small little magnet on there, and then a piece piece of metal on there. So that works out good. It's quick. So anyway, let me take you out and show you my idea out in the main shop. Purchased a couple other Spillmaster cups, and also picked up some water-soluble oil for my bandsaw. So let me fire up the iPad here. If you guys follow Ox Tool, you'll see in the past where he built a toe jack out of a bottle jack for lifting equipment. And then following that, James Kilroy showed his Enerpac unit. That's what this is here, is the Enerpac. It's not going to show up. Let's see. There it is, for machine lifts, hydraulic machine lifts. Anyway, I really liked this unit, and been thinking about it ever since I saw it on James's channel. And they give you the dimensions of the unit, the different lifting capacities. One's 8 ton and one's 20 ton. Well, kept looking at that and thinking about it, and I've got a Porta-Power, a Jet Porta-Power ram, and got the full kit, and kept thinking about it and saying, well, it's, you know, geez, if you look at this, it's nothing much more than a Porta-Power ram in there. So I went in my scrap bin and found a piece of tubing, square tubing, and found another piece of square tubing that fits inside of it. So these are a little bit, grabbing a tape measure. This tubing is basically 4-inch tubing, and inside is 3 1/4, and this is 3-inch tubing. So my thought is that this tubing will end up registering down inside of this tube, and that will be my jacking mechanism, similar to here. They have this piece here. If you can see, let's see if I can blow that up. On their unit, they have like a dado with a key in it to register the ram as it goes up and down. And so my thought is, rather than going through all that effort, is just go ahead and use the square tube. And what I'm going to do is end up cutting a window in the face of the square tube, and in that face of the square tube would be this is what you would end up seeing. This would be shown, and then that's where the actual toe piece, just like that, would attach to the front of here, and it would be course back, it's a 1/4 inch thick, so it's going to be sitting back on this face, but it'll be built deep enough so that it reaches and registers. Hope all that makes sense. And then on the back side of the lifting tube, basically cut a notch out so that the ram would sit, I'll just keep you guys in frame there, so that the ram would just sit right down over the ram. And then up top here, on the top of it, of course I'm going to cut it off, and I'd end up welding a plate on top of it. Also, in the base plate down here, and in the top plate over here, which will sit up here, I would go ahead and make registers to hold the 2 removable parts off of the jack. So those would actually lock. Well, I think I just caught the camera shutting off, so I'm going to kind of take a guess here where I was talking. I was discussing that this had a nasty weld in the back, and of course it's going to interfere with this tube running up and down. But it's really not going to be an issue. The weld's only on the one side where it was seamed, and so when I cut this window in the front here, I'll cut it where the weld is. So the weld will go away, and then the top and bottom, I can just reach in there with a grinder and clean it up. And then for any slop within the 2 tubes, I can just go ahead, was thinking about that too, and I can just go ahead and drill and tap and run some set screws in to act as guide mechanisms. So I think it may work out well, and it really won't be much larger than the Enerpac unit. The Enerpac unit is the 8-ton is total body height is 12 inches, and I'm thinking this whole unit is going to be somewhere about 14 inches. 14 inches, there you are, back in the camera there. So anyway, I thought I'd share that with you. If anybody's got any comments on it, ideas, love to hear it. End up putting the same type of handle on it so you can pick it up. And interesting enough, the Enerpac unit weighs 60 pounds for the 8-ton and 100 pounds for the 20-ton unit. Quite a load. Based on just lugging these guys around, I think I'll be hard pressed to reach the 60-pound limit, but we'll see. Okay. Anyway, that's the quickie for today, and hope to get some more videos out soon. Thanks again for watching, and thanks again for the new subscribers. I appreciate those fellas, and talk to you soon. Hi guys, it's Chuck. Welcome back. The Enerpac, it's not going to show up. Let's see. There it is, the for machine lifts, hydraulic machine lifts. Anyway, I really liked this unit, and been thinking about it ever since I saw it on James's channel. And they give you the dimensions of the unit, the different lifting capacities. One's 8-ton and one's 20-ton. Well, kept looking at that and thinking about it, and I've got a porta-power, a jet porta-power ram, and got the full kit, and kept thinking about it and saying, well, it's, you know, geez, if you look at this, it's nothing much more than a porta-power ram in there. So I went in my scrap bin and found a piece of tubing, square tubing, and found another piece of square tubing that fits inside of it. So these are a little bit, grabbing a tape measure, this tubing is basically 4-inch tubing, and inside is 3 1/4, and this is 3-inch tubing. So my thought is that this tubing will end up registering down inside of this tube. Here are the two brackets I'm making to hold the foot. And I'll kind of go backwards here from where we're at right now. Right now I'm just cleaning them up, and as you can see, if this camera's focusing, there's the weld there that screwed up when I sectioned this piece. I didn't see the weld. It's going a little too fast. And what I have is a piece of square tubing, and of course you can see on the mill, when I sectioned it wrong. What I'm doing is, this is the bar for the foot, and it fits into here, so I'm making some angle iron out of this tubing, and I don't have any angle iron that was the right size. So what I ended up doing is, and you can see this piece here on the bandsaw over there. Trying not to move the camera too fast. I sectioned off this one piece so that I ended up with a U shape, and then I sectioned it in half again, to go ahead and create my L brackets. And the L brackets will end up sitting right here and right here. And there's where the foot will be. So right now I'm just set it up here on a pallet, and I'm cleaning them up so they're both the same size, and then I will mill that weld out of there also. So be back with you soon. Well, here's a little update. I've machined the pieces here on the sides so that it'll fit to hold the foot. End up with a little bit of reveal there for welding, and I think that's going to work out good. Do a little more detail work to it. The front of the column ends up flush with here so that the foot will come across and go all the way to the ground. So actually when I laid out my center, it's off. I've got to relay that out. And what I'm planning on doing is, here's the porta power jack, and so what I'm planning on doing is going ahead and machining a pin. Got a piece of steel here. This is a pin that works for the porta power, but machine a pin, and then I will go ahead and bore a hole, fit the pin, and then weld the pin in place, and then the porta power will end up sitting on top of that pin. And that's what will align it and hold it into position. On the top of the ram, what I'm planning on doing is drilling a hole, and this pin will go through the hole, and it'll bear the weight as it pushes right here on this shoulder. So a little update. It's getting closer to getting to maybe put it here together. Okay, be back with you shortly. Just another quick little update. I thought I would mention it. So this bottom piece is the outside of the column. I've just cut off a section so it's easier to work with, and that was a torched end that I just cut off of it. And then this piece here will be cut, and that's going to be the ram that the jack pushes up and down on. I'll weld when it's cut, weld a plate on the top, and this dowel will be coming up through that plate. But one of the discussions was how I was going to take care of the clearance problems between the two column pieces here. And it turns out that a piece of 1/8" strapping is just the perfect what's going to be the bearing surface. You can see I've got one on each side there, and so I'll end up putting it on all 4 sides, and that's what the column will end up riding against as it goes up and down. Just go ahead and tack it on there, drill a couple holes in it, and throw some tacks on it, and I think that'll work well. That'll work on all 3 sides. I've got to figure out the front here, because this would take up too much space, the width of it. May go to just a thin piece on each side. So working that out still as I go. But I think I got the bearing surface worked out. No reason to use Delrin. This metal strapping will slide fine with a little bit of grease on it. Okay, so continue to move on here. Well, here's just another little update in the build. So I've drilled the plate, the bottom plate, and then machined a pin that'll get welded in place. And then the porta power will come down and sit on top of the pin to hold it in place. So the back side of this, the outside column, will have a window cut in it high enough so that so as this comes down, it can be over, come across, then sit on the pin. Hope that makes sense. You'll see it in the finish. Okay, so just a quick update, moving forward on it. Here's a quick shot using the slitting saw to cut the window in the tube here. Seems to be working fine. Got the cool mist running on it. I'm using the auto feed. Be back with you later. So this is just a little follow-up after the first cut. I did go full depth on the cut. The silting saw is a eighth inch saw in the thickness of the blade, and I did cut full depth. I went all the way through. I don't think you can see inside the tube or not. I don't know. But there's a shot inside. So we'll end up turning it over, and if that helps or not. Turn it over and make another pass. And then I still have to figure out how to use an end mill to cut the other direction. Well, here's a little in-process look at it. I think I'm going to go ahead and move the ram against the front face and put a 1/4 inch spacer in the back, and then stay with the 1/8 inch spacers on the side. And these two pieces right here will be the rubbing. That'll be the rubbing surface on the back side of the column as it goes up and down. That means that I've got to reposition my pin that I put in there, but that's not a big issue. So just a little in-process shot of it. I think it's going to work good. Still making a little bit of adjustments as I'm going, and then this guy will be going up. Okay. So just a quick view, and we'll be back at it. Catch you soon. Well, here's another update in the build. On the column, I've got the back window in it for the pump, and then I've got the first of the keyholes. There'll be some more there. I got to lay those out. But I got the first of the keyholes done, and I've built the toe. So the toe sits down in there like that. I've opted to go with the 3 inch right now, which may be a little long. I have to decide on that. It's kind of a run and gun as I go here. But the other change that came about in this is you can see the toe is even with the bottom of this column, and I'm going to section out this piece here and this, so that it'll sit as low as possible. So I'll be bringing you back and show you some more. I think I just found an error. Well, we'll see. Be back shortly. Got to do some more figuring here what I just did. Well, I mentioned I found an error, so I thought I would throw this together real quick just to show you where it's at. Pretty much all the parts are built here. Like I said, I'm going to space the back by a 1/4 inch, have the 1/8 inch spacers on the sides, and the front will ride against the face here. I've made the top piece for the ram. So the ram is inside. It's accessible. I'll show you later how the hose connection works. It's simple. But I did make a little error here. As I said, I was going to take out this piece so that the toe would sit lower. And when I laid out the holes for the toe, I laid it out so that it would end up flush on this piece of metal, and that's not what I want. I actually am going to section this bottom piece of metal right here so that the toe will end up on the ground. So what I'm going to do is basically fix my mistake here and just make these keyhole slots deeper on this bottom one. I'm not going to go back through and make a whole nother one. I think that's my fix, unless I change the toe. I'm going to work on that one to see which is the lesser of the evils on how to do it. And then I still got to work out the finish of the feet. But just another little show in the build. And I'll show you, it's nice that I've learned how to use CAD. It was a simple way to figure out the keyholes using CAD to line up the holes and figure out that and how much the overlap was. All right, be back with you. Well, I don't know if this will show up, the blue font on there, but you can see this is what I used to figure out the keyhole. I had the bottom dimension, the diameter, and then the larger keyhole, and then figured out the distance, and then it gave me the total distance of cut. So it's a quick way to figure it out. Thought I'd share that. Well, here's just another quick update. The build in progress. As you can see now, I did notch the plate here so that the toe can go all the way to the deck. And the toe that I built, as you can see, stops even with the plate right here. So I'm going to have to make a new toe. Not a big deal. Just cut it up again. Other than that, it's getting real close to a little detail. Visit to the glass beater, and then start welding. So anyway, here's an update. Be back to you, and then hopefully in the next one it'll be painted, and we'll be giving it a test lift and see how it does. Catch you soon. Hey guys, welcome back to another episode of Tool Time. My name's Chuck, and tonight I want to show you a new tool. It's called a Mitchell. And you're probably going, wait a minute, Mitchell? I thought it was a TOEJACK. Well, I'm calling it a Mitchell, and I just want to do a little story here and why I'm naming it the Mitchell. I have a friend that we actually grew up in the same city, and probably within 800 yards of each other, maybe a little more. Ended up going to different schools though, but played in the same neighborhood, same creeks, but don't remember him from those days. And a couple years back, joined a poker group with some friends here in the neighborhood. And they were from a Porsche car club, most of the guys, and I met Steve Mitchell. And it was funny that we started talking and finding out that our paths may have crossed in our childhood, either at the creek or at the Navy base or who knows where, library. But became friends, and it turns out that my wife and Steve went to the same junior high school together. So there's some ties there. Well, anyway, I'm calling this tool to Mitchell because I'm dedicating this tool to Steve. As I mentioned, he's a friend, and he's roughly the same age as I am, and he was diagnosed with cancer and had to go through some amazing surgeries. It was facial cancer in his jaw, and they had to take a bone out of his leg, and he's gone through a horrendous amount of surgeries and recoup time, and he's still not done yet. He's got a long way to go, and he's tough. He's versatile, and that's why I'm naming this tool after him. I'm hoping this tool will be half the person that he is, and hopefully it'll be tough and versatile, and Steve's got a great work ethic, and another thing that's enamored my friendship with Steve is some of you may know that my youngest son is a special needs child. Well, Steve and his family, his wife, Jackie, years back, roughly 20 plus years, they adopted a special needs child. And that's quite a huge undertaking. It's a life changer. We didn't have an option. It's our son, and we love him, and we're thankful we have him. But to take on the adoption of a special needs child is a heck of a challenge and a heck of a credit to a person. And so, again, that's my reasoning and why I wanted to call this the Mitchell. And mentioning this to everybody, I just hope that you'll have Steve in your thoughts. Tend to believe that those types of things help people, and know that he'll make a speedy and final recovery and get back at it. He is doing well, though. Okay, so I got the parts of the Mitchell here laid out, and I'll move the camera up a little closer, and we'll go through the parts and assemble the Mitchell. Okay? Well, unfortunately, I don't have the ability to see what my camera sees when I'm standing in front of it. So I'm going to do my best here. Just looked at it, and it looks like we're in the viewfinder. So we'll go over the parts. The fun thing about this project was that all of this came out of scrap that I just happened to have in my shop. And I always enjoy that I never had to leave the house and just go in and start finding stuff and to build. So to start off with, there's the body itself, the window that was cut in the front here for the internal ram, and then the window in the back for where the pump will come through. So this is a jet. It's a 4-ton capacity porta-power, and so for this to go in, it basically comes down and sits over the pin and then slides into place. Things are a little tight from when I finished with the paint, but anyway, that puts the jack into place. The ram itself, I cut the 4 keyholes in it for the toe, and then I ended up welding a piece of strap, 1/8-inch strap on the sides, and then 1/4-inch straps on the back to take up the clearance. So this guy basically sits down right inside, and get it aligned, which of course is going to be a problem with me right now because I'm on camera. Okay. All right, I'll fight that in a second. It fits though, trust me. The next thing are the feet which extend. These slide in both sides. Again, a little tight with the paint, and they can either be all the way back or come forward. there's Allen screws here on each side that go in, and then those are what keep the feet from falling out, so that they can slide forward. Allen screw stops on the body, and I have the full extension of the feet there. The toe itself ended up, I decided not to change it at this point. Just really need to play with it and experiment more. But so I left the toe fairly large, and gonna work with it and see how that works. And that basically slides down into the piece here. Okay, there it is. All right, and then in the back here, oh, that's where I screwed up. My bad. Maybe that's why something was trying to tell me that was one of my issues. Okay, just got to take the ram out. The porta power pump has to sit like that first. Take the plug out. And make the connection to the pump. Wrestle this guy around. Okay, come on, baby. So, tighten the hose on. Then the ram goes into place. There we go. And then this ram sits down on top of it. And I'm going to have to fight it for a second to get that to line up. Okay? And that goes in, and we're ready to work. Hopefully I'm still in frame there. So, as I said, the Mitchell turned out well. I'm real happy with the product. My dirty fingerprints on it, and already scratching it up. Got a handle to carry it around. I'll have to get a scale and weigh it and see what it actually ends up weighing. I know it's not near the weight of the Enerpac unit. So I hope you enjoyed seeing it. I appreciate all the comments that came in from the viewers. Lots of great ideas and different thought processes on how to build it. But I'm real happy with how it turned out, and hope you enjoyed the video. I didn't show, I have to apologize in some regards. I mean, part of this is about machining. But I really didn't show much of the machining, none really. A lot of the machining was fairly basic. There's better channels to watch for instructional machining. Myself, I'm a home hobbyist, still learning, and it's hard to film and do the machine work at the same time. Plus, I'm an impatient fella, and once I get going, I go. And the same thing with the welding. I'm not the guy to watch weld. I can make things stick together and feel confident that my welds are good. But there's lots of other guys out there to watch that can teach you how to weld. I MIG welded all this, was the type of welding process that I used. Okay, hope you enjoyed it, and we'll have to see how this puppy works. All right, well, thanks for watching. Just adjusted the camera there. Paint made everything, the clearance is a little sticky, but as you can see, the ram's in, and thought I'd show you working away. See what kind of lift we got. That's something I hadn't really even looked at yet. Grab a tape measure. There it is right there. So we get almost 5 inches. 5 inches of lift. And it doesn't appear to need a spring to do any kind of return. Okay, thought I'd show that to you. Okay, I bet you guys want to see it lift something, right? Alright, so this is my surface grinder. It's a Brown and Sharp 2B if I correctly remember. And it weighs about 2,000 pounds. So I set it up on this side over here. It's tight quarters back here. I'm gonna so I've got the TOEJACK set there underneath it, and we'll give it a lift. I'm gonna try to film this and pump at the same time. So pumps right here, and here we go. It's engaged, and we have liftoff. Looking good. And have good control for letting it back down. So it works well, not a groan. So for shits and giggles, let's pull it out and extend the toe there. So we got a lot of the toes sticking out, and let's see what she does. I haven't tried this, so we'll see what happens. Leaning forward there. So quite a bit of cantilever, as you can see, as it picked it up off the ground, even with the feet extended. Let's see if I can get down here, and let's back that out. Feet are all the way extended, so we'll kick it in a little bit more. Try it there. Okay, still lifting. So it's lifting at that. It just walks the back up just a hair when it's pushed out that far. Let's see why. Feet are all the way extended. Kick it in a little further. And lifting fine. Okay, so going to be a little more R&D on it, a little more play with it, but generally, all in all, the principle works well. As you know, it's a copy of an Enerpac unit, and I'm happy with how it's come together and worked out. Hope you guys enjoyed. Oh, geez, try to get back up off the ground here. I'm going to grab the scale. I forgot to go get that, but carrying it back here, it is a bit of a load. I don't think it weighs anywhere near the what the Enerpac weighs. Okay, I'll be back with you here shortly. Okay, I got the old bathroom scale out, and just a reminder, this was the Enerpac unit that I modeled it off of, and that Enerpac unit weighs almost 60 pounds for the what is it, the 8.5 ton, and for the 20-ton unit, whopping 100 pounds there. So mine's a 4-ton unit. Let's see what she weighs. Yeah, 30 pounds. Let's call it roughly 30 pounds. Not bad. It is a little bit of a load. And then just to finish up on discussion on the toe, as you can see, the toe sits off the deck by about quarter inch, 250 thousandths. Whoops, didn't have that in frame, but about 250 thousandths. I may rebuild the toe so that it sits flush on the deck, pick up that quarter inch. But my experience in machine moving, most machines sit flush to the deck. As you can see, my surface grinder was sitting up on pads, so the unit could slide right into it. But most machines that I've moved, my mill, my bandsaw, and what others, the drill presses, they all sit hard on the deck. So you're first in there with a pinch bar and some wood wedges or stack blocks of wood, and get it up in the air with a pinch bar. And then that's where this would come into play and go ahead and put the toe jack into place. The interesting enough on the Enerpac unit there, you can see that toe is 3/4 of an inch. So there again, you need to wedge the machine up before you'd ever use the Enerpac unit. So I'm happy with it the way it is, but we'll play with it. One of the thoughts that Buddy had was to make a toe that was longer in width out of angle, so that way you could pick up a complete side of a machine instead of just in one point of the machine. Kind of a neat idea, but I don't know. Anyway, hope you enjoyed the video of the Mitchell. And to my buddy Steve, I wish you well, and talk to you soon. Look at that, wearing the paint off already. A little bit of load against that face there as it was lifting. All right, guys, thanks. Thanks for watching. Again, thanks for all the encouragement during the build, and some of the thought processes and inputs, all valued, all good. A little bit of a team build here, and I appreciate it. Take care.